So you built a traditional web application where you render a page to your users, perhaps using HTML, CSS, and JavaScript. Perhaps you even have some fancy animations going on, but it still doesn't feel that alive. Perhaps you want to build the next food delivery app where you can track the driver in real time, or maybe the next Discord in the browser where multiple users can chat with each other, or even a video conferencing app, or perhaps even a fast-paced multiplayer shooter in the browser. What you want is real-time communication, often between multiple different clients. A naive approach is simply to continue as you're already doing, making HTTP requests to a backend server for updates. Just keep on asking the server for more updates. And this is kind of like sitting in the backseat during a road trip and continuously asking the server, are we there yet? That poor server is going to grow tired of you pretty soon. This approach is called polling, and it's one of the easiest to implement, which is why it can be worth it if you don't have a lot of data, or maybe your data isn't changing that often. Then of course you can just keep on asking the server for more updates. Another alternative is to use a technique known as server-sent events. In this case, the initial connection is maintained and the server can keep on sending back updates to the client. This could, for example, be used in a dashboard where you want to update some metrics at a fixed interval. Now keep in mind that this is still not bidirectional, so your client can't randomly send another message to the server. It would have to initiate a different HTTP request for that, which of course adds a lot of overhead. Another more uncommon approach is to use a technique known as chunked transfer, and this is when you perhaps have a large buoy like this that you want to send over to your client, and you don't want to send all of that data immediately. Perhaps you don't even have all of that data available and you don't know the size of the output. Well, you can split him up into multiple pieces and start sending the data as you get it. You can start sending a little piece of that data and render it immediately in the browser, so the browser doesn't have to wait for all of the data to be received first. This is of course still not bidirectional, and you also get that annoying effect of an ever-spinning refresh button because the initial request is actually not completed yet until all of the data has been sent. Another more common approach for implementing real-time communication is with the help of WebSockets, and this is a protocol that is different from the traditional HTTP protocol. In this case, we can actually send data in both directions. We set up a persistent WebSocket connection with the server, and we can send the data in both directions as we please. The API is actually quite simple, and it's supported by many different backend libraries and frameworks as well. WebSocket overcomes the overhead that is associated with sending all of these HTTP requests. We can have a much smaller protocol where we can send data in both directions. Another alternative to WebSockets is WebRTC, which literally stands for Web Real-Time Communication, and that is exactly what we are doing, right? WebRTC is a lot more decentralized. It actually allows you to connect directly to a peer without having to have an intermediate server. So you don't have to be worried about a server spying on your really confidential data here. Bob can actually connect directly to Alice's computer, often without having to have an intermediary server. WebRTC goes hand in hand with the new Media Streams API, which actually allows you to have things like video and audio streams. So you can actually have video streamed in the browser, or even microphone data that is being captured by your microphone. You can even do things like screen capture with the Screen Capture API to stream your screen or a browser window to a different peer. One of the main differences between WebSockets and WebRTC is that WebSockets use the TCP protocol while WebRTC uses UDP, and this changes the reliability quite a lot. With TCP we actually have message acknowledgement, so when a message is sent, the server will also respond and say that it has received that message. In the case that the message was not received, if it was dropped, then it can actually be retransmitted and have that handled automatically by the TCP protocol. And this is different from UDP, where if a message is dropped, it is simply lost forever. So this makes WebRTC much more suitable for these sort of real-time scenarios where you have perhaps a multiplayer online game or a video conferencing app, where it doesn't really matter that much if a single frame is dropped. It's not like you're going to notice it anyways. Now, due to its decentralized nature, WebRTC actually has a little bit more of a handshake logic that can be a bit intimidating. There are, of course, a lot of different libraries available that will help and facilitate this, so it's generally not a problem in practice. I also want to mention Web Transport, which is actually a completely new way to enable real-time communication between clients. And this is implemented with the new HTTP 3, which is a new specification of the HTTP protocol. Of course, this is actually not that compatible. It is only available in the most recent browsers, which is why I will not be covering it more in depth in this video. So how could we use WebSockets in a practical project? Well, there are multiple different libraries available we can use to facilitate communication, but honestly, the built-in browser API is often good enough for most use cases. We can create a new connection by simply providing a URL to where we want to connect, and then we can attach event listeners to this WebSocket instance. We could add one, for example, on the open event, so whenever a connection has been established, we could log something to the console. Here I've just implemented a very basic WebSocket server in Node.js. We also use Express, but realistically, we only need to have the HTTP module and the WebSocket module available. And clicking the connect button, now we can see hello world printed in the console. If we take a look at the network tab, we can also see that we are making a request to localhost here, and here we can also take a look at all the messages. So now when a connection has been established, we send hello to the server, and when we receive a message, we also print that to the console. This is very simply implemented here in the Node.js server as well. We just echo back whatever the client sent to us. So let's try this out. If I now press the connect button, we can see hello world, we can see cool hello, since that is just what is being echoed back. And we can also view this now in the DevTools network tab. Now suppose we want to build a chat application like I mentioned previously. We can do this very easily with the help of the WebSocket API. Here I just set up two input fields, a name and a message, and here I can connect to this chat room and start sending messages. If I were to open another tab and connect with a different user and start sending some messages, we can see that this message has been sent to all of the clients in the chat room. How does this work on the client? Well, it's very similar to what we did previously. Now instead we just take in the name from the name input field and we pass it on into the URL that we actually connect to the WebSocket server. And then when we receive new messages, we simply append those to the messages divider. When we press the send button, then this little send button here, we take whatever is present in this message input field and we send it with the WebSocket connection. How does this look on the server? Here we have a Node.js server. It works pretty similarly to before. Now we just simply also have to parse the URL. In order to get this name query parameter, we need to parse the request URL. But other than that, we can simply pass this on and create a new user object. And this is what we need to have to keep track of all of the connections so that we can broadcast messages whenever a new message has arrived. So we simply push that to a connections array and we broadcast here that the user has joined the room, which simply loops over all of the connections and sends a WebSocket message to them. And when we receive a new message from a specific WebSocket connection, we just decode this message into a string and then we broadcast it further to all of the other clients so that they will have it displayed as well here. This WebSocket backend can of course be written in any language or framework that you please. Like I mentioned, WebSockets are quite widely adopted in pretty much every standard web programming framework, so to speak. So here's an example in Golang. It's very similar. We're just using the Fiber HTTP server, which has a built-in WebSocket middleware. And it just takes in the query parameter, creates one of these user objects, adds them to an array. It works pretty much exactly the same way. When we broadcast the message, we simply loop over all of the connections and send the message to the connection. We can see that we can connect here. It works exactly the same way as the Node.js variant. And just for reference, here we have another little flavor in Python that does exactly the same thing, just using the fast API module. Also super straightforward. So like I mentioned, WebSockets are quite ubiquitous. There are lots of support available for them. So whatever backend language or framework that you wish to use, it's most likely the case that there is WebSocket support available for it. Now, there are also libraries that provide more abstraction over the WebSocket protocol, perhaps to add extra features. And one of these libraries is called socket.io. It adds some nice features that you might wish to use, specifically if you are using a Node.js backend. So this socket.io library has its own protocol, which makes it necessary to also have a server component. So if you wish to run socket.io, it might be more difficult in different backend frameworks and languages, but there is of course a library available for JavaScript specifically. That is I think the most officially supported backend language. So what does socket.io actually provide? Well, it provides reliability. So if WebSockets are not available, there's actually fallback transport. It actually falls back to using polling, which we discussed previously. So if in the case that WebSockets are not supported, then we can actually use polling. It will automatically use that as the transport method under the hood. So it's more resilient to different edge cases or different browsers that perhaps do not have WebSocket support. It also handles automatic reconnection, so it checks if the connection is lost or dropped, then it will actually automatically reconnect to the server. It also provides a really nice feature called events, which will handle the case of sending notifications to a specific type of category. Say you want to have notifications grouped specifically, then you can send these messages to a specific event called notifications. So you can have a hello event, for example. Here in the client, we add an event listener for the hello event, and on the server, we emit to the hello event. So in this case, we will only get these hello messages sent to the callback function that has the hello tag. There's also a concept of rooms in socket.io. We can join different rooms, so we can have some sort of different categorization or grouping in the server where we can join different rooms and have the clients isolated from each other. So this provides a really nice little layer for us that we can use directly. If we want to have different chat rooms, then in this case, only client A and client B will get messages if they are in the same room, my room. Socket.io is also scalable. So in the case that you have multiple different servers that you wish to connect and send a message to all of the sockets that have been connected to these servers, well, we can use a different adapter for that. We have, for example, this Redis adapter, which will publish the messages to Redis first, and that will be propagated to all other servers, so they also send this message to the clients that have been connected. So here's an example of how this can look with the Socket.io client and server. We can actually see that this is quite minimalistic. We don't have to write a lot of code. Like I said, it's quite a nice abstraction in general over the base WebSocket API that we have. Here we can just set up a new socket with the IO function. We pass in the backend URL that we wish to connect to, and in this case we can pass in query parameters in this way. So here we just pass in the name parameter, and then, like I said, we have different events. So in this case we have a message event, and this will directly be parsed as a string. So in the case that we have a message, we simply append to the messages divider just like before. And in this case, we just emit a new message with the value that is in the input field. Quite similar implementation of the backend. Here we just create a new socket.io server. So here we can emit a new message with the message event, and this will call all of these callback functions in the client that have attached to this message event. So now let's try to implement something similar with the help of WebRTC. First, we need to understand a little bit how the handshake logic works. So suppose you have two peers, one called Bob and the other one called Alice. Well, Bob wants to connect to Alice, so he sends an offer, and that generates a string like this. It looks a bit intimidating at first. It simply describes Bob to Alice and the different capabilities, network capabilities and protocol that Bob wishes to use. So this is the local description of Bob. This is what Bob says that he is. And then we have a remote description generated by Alice. So Alice actually creates a remote description that she wishes to send to Bob. So she answers to Bob by also generating such a string. And this answer will be the local description for Alice, but the remote description for Bob. So we kind of have two opposites. The local description of Bob is the remote description for Alice, and vice versa. The local description of Alice is the remote description for Bob. So here we have a very simple example that is very reminiscent of the WebSocket chat that we have, but now instead we have it written with the help of WebRTC. So how does this work? Well, we can start by creating a new offer, and this will be our local description. This describes the local client. And that is exactly what we wish to input in for the other client as the remote description. So the remote description of client B will be the local description of client A. And then we can answer client A by clicking this create answer button, and it will create this sort of answer SDP, which we can then pass on as the remote description for client A. And then when we press set remote, the connection has been initialized between the two peers, and we can start sending messages between the two. Here I'm just using the already built-in WebRTC client that exists in the vanilla JavaScript API in the browser. Here we just create this new RTC peer connection class instance, which we attach some event listeners to. So when we have an ICE candidate, that simply means that we have generated an offer and we have a new local description. So we can show this local description value, and we can also make an offer here. So this is where we actually make the offer by calling create offer, and then we set the local description to be that offer. And instead, when we make an answer, well, we take our remote description that we have passed in, and we set that remote description and create an answer for it. And then whatever that answer is, well, that will be the local description in our case. And the same goes for set remote. So when the client A presses the set remote button, well, it will simply parse the value that we have in the remote description box, and it will set that as the remote description. Now you might be wondering how to actually establish a connection if we have to handle these sort of weird handshake objects. How will I actually send this offer in the first place to the other peer? And this is a reasonable concern, of course. And the usual way to solve this is actually with the help of a server. This is what is known as a signaling server. So this is what sets up the initial connection between the two different peers. Bob will simply here send his offer over the server, and the server will tell Alice about him. And then Alice sends her answer back to the server, which will be propagated down to Bob's client. But after this initial handshake has completed, well, then the connection has been established directly between Bob and Alice, so the server is no longer of any use. The actual data stream is directly between Bob and Alice, and no server will be able to see those confidential cat pictures. So now you hopefully have a little bit of a better idea on how to implement real-time communication in your web applications. There are many different alternatives available depending on your needs, depending on your reliability needs, your performance needs, if your data is large or just small, and also depending on the frequency that you need to transmit data. Feel free to leave me a comment below if you have any questions or feedback, and also feel free to join my Discord channel. Thanks a lot for watching. See you in the next video.